Okay, we have two parallel lines here. Here are our equations for them. 4x plus 3y equals 24. 4x plus 3y equals 48. So they're parallel lines, meaning that they don't cross. They're in the same plane and they don't cross. And also another way of thinking about it is that the distance between the two lines is always the same no matter where we measure it. Of course, then the question is, how do we measure the distance between two lines? Well, we could kind of measure it in a few different ways. We could talk about the horizontal distance between the two lines, just going straight across, which in this case is like 6 here and 6 up here. Or we could talk about the vertical distance between the two lines, like right here, which is 8 units, and down here, which is also 8 units. But really, technically, when we talk about the distance between two lines, we mean the perpendicular distance, or straight across, which is always going to be the same. So let's go ahead and calculate that perpendicular distance. Plus, this is good practice for writing equations of lines and finding intersections of lines and distances between lines and so on. So let's start by writing the equation for this line right here. And then we're going to, after we write its equation, we're going to find the point of intersection between this line and this line here, and then once we find that point of intersection, we can find the distance between the two. So let's go ahead and do that. So the slope of this line, the slope of these two lines here is negative 4/3, which we can just get quickly from the equations, or you can just kind of look at it, negative 4/3. Since this is going to be perpendicular, it'll be 3/4, that negative reciprocal. You take the fraction, flip it upside down, and make it change its sign. So to write this equation, let's see, let's call this AB. So AB, its equation will be y equals mx minus h plus k, where m is the slope and hk is a point that's on the line, which we have here. It's the point 60. So we have y equals 3/4 x minus 6 plus 0, or y equals 3/4 x, and let's see, that's 18/4, which is 9/2, right? 18/4, 9/2. Okay. So there's the equation for that line. Now we got to find their point of intersection. So let's see, let's call this point C up here, so I can call this line CB. So let's see, CB intersected with AB, or basically finding point B. Let's see, our equation for B, we're going to write it in y equals mx plus b form, is y equals, let's see, negative 4/3 x plus, oh, not 48, 48 divided by 3, which is 16. So we're going to set these two equal to each other. I have negative 4/3 x plus 16 equals 3/4 x minus 9/2. And here's how I'm going to get my calculator out. Let's just pause for a second. Okay, so let's see. We'll add 4/3 x to each side. So 3/4 plus 4/3 is 25/12. So we have 25/12 x. And we're going to add 9/2 to each side. So 16 plus 9, ABC2, 20 1/2, which is 41/2. I'll divide both sides by 25/12. Divide by 25/12 gives us 9 21/25, which is 246/25. And let's see if that kind of pans out on the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, and almost 10. So that works. Now we just have to substitute that value back into one of the two equations in order to get a y value. So we'll go over here, we'll go y equals negative 4/3 times 246/25 plus 16. We'll let the calculator do all that. So let's see, times negative 4 ABC3 plus 16 gives us 2 and 22/25, which is second ABC, enter, 72/25. See if that pans out. Look here, 1, 2, and just a little shy of 3, so that works. So the location of point B is 246/25, comma 72/25. That's really ugly coordinates there. Now we have to find the distance between these two. So AB equals, let's see, 6 minus 246/25 squared plus 0, let's see, minus 72/25 squared, and this is just something we're going to punch in the calculator entirely. Actually, we'll do the... Alright, so we have 6 minus 246 ABC 25 squared plus 0 minus 72 ABC 25 squared. 23 and 1/25, which is square root of 576/25. And we'll get an approximate value on that. Oh, I don't know. Exactly 24/5. I take away that approximately. Exactly 24/5. Oh. Derpy derpy derp. Of course. Hold on a second. Okay, so let's test and do the same thing somewhere else, and we should get 24/5 again. All right, so we're going to do up here. We'll find the distance across here, and we should get 24/5 again. If we do, then we've verified that the lines are parallel. So let's do it again. So next, finding the equation for this line right here. So let's do that. Its slope is 3/4, just like the last one, because it's perpendicular to the same line, and it passes through the point 312. So let's see. Let's go up here. So we'll call this CD. And we have y equals mx minus h plus k. Y equals 3/4 x minus 3 plus 12. Y equals 3/4 x. See, minus 9/4, negative 9/4 plus 12 gives us 9 3/4, which is 39/4. Okay, I just did my distributive property and added the 12 on afterwards. Okay, so next we're going to find the point D down here, which is the intersection of CD and AD, which is point D. So we'll take the equation for this line over here. Okay. So we're going to have to rewrite this in y equals mx plus b form. Let's see. y equals, let's see, negative 4/3 x plus 8. So very similar to the last one, except for the y-intercept is different. Alright, so negative 4/3 x plus 8 equals 3/4 x minus 39/4. Okay, so let's see. We'll add 4/3 to each side. We've already done that actually on the previous one, so we get 25/12 x, and then we'll add 39/4 to each side. So let's see, we have 8 plus 39 over 4, 17/3, which is 71/4, and then we'll divide by 25/12. Gives us 8 and 13/25, which is 213/25. Uh-oh. We have a problem here. So that can't be right. We're going to pause for a second while I sort this out. Found it. That should be plus 39/4 right there, not minus. Which makes this plus 39/4, which means that we have 8 minus 39/4. 8 minus 39/4, which is negative 1 3/4, negative 7/4, which will divide by 25/12, and negative 21/25, which looks about right. You see there's point D right there, which is a little bit less than 1, negative 21/25. And now we got to find the y coordinate there. So we'll plug this value back into one of these two equations. We'll pick, I don't know, this one up here, negative 4/3 times negative 21/25 plus 8 equals y. Let's plug that in here. Times negative 4/3 plus 8 is 9 and 3/25, which is 228/25. And does that pan out? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just a little bit more. 9 and 3/25, so just a little bit over 9. Perfect. So the location for point D is, let's see, negative 21/25, 228/25. Now find the distance between these 2 points. So find CD equals, okay, so we've got 3 minus negative 21/25, which makes that a plus, minus 12, or plus 12, minus, and we have 228/25 squared. So let's see. Punch this all into the calculator. We have 3 minus 21/25 squared plus 12 minus 228/25 squared gives us 324/25. 324/25. That's 18/5. 24/5. Something's wrong. All right. Well, hold on while I sort this out. All right. So first, I just went over to my geometry software here, and I sketched these two lines here, wrote the equations out for them, drew a perpendicular between them, and measured the distance on that perpendicular using the software, and I came up with a 4.8, which means that my first calculation was correct. My second one is off. And then I go back here, and I took a look, and somehow I just punched something in here wrong, and this really is 576, which gives us 24 over 25, or 24 over 5. Okay, so again, overall big picture here, that the distance between two lines is just like the distance from a point to a line. It's that perpendicular distance. So if we need to find that, it's kind of a complicated process. We have to find the equation for the perpendicular line. We have to find the point where they intersect, and then we have to find the distance between those 2 points. And we did it twice here. So again, we found the equation for AB. And then we found the place where they intersect by setting the two equations kind of equal to each other. First we solve for x, then we plug that x value in, and we get y. And then once we have an x and a y, we could plug them into the distance formula over here and find the distance between them. And that's the distance between the two lines. And we did the same thing up here. Found the equation for this line right here. And then we put the x part, those two equations, the y equals mx plus v, set them equal to each other, solve that for x, plug that value of x back into one of the two equations, both if you want to be certain of it, to get a y value. And once we have an x and a y value, since we already have 1 point on this line, and we have the other point over here, we can find the distance between them, and hopefully if we don't make any stupid mistakes or punch something wrong into the calculator, we get the same value as we did before, which after a little poking around we did. There you go.